this section deals with basic trig identities, and trig identities are relationships about trig functions that we know are true. So the first 4 slides of it, or the first 3 slides of this, are just going to be giving you some of those trig identities. So the first set of trig identities that we need to know are our reciprocal identities. We've already talked about these a little bit. Sine theta is 1 over cosecant, cosecant is 1 over sine, cosine is 1 over secant, and secant is 1 over cosine. Tangent is 1 over cotangent, and cotangent is 1 over tangent. So those are some relationships that we know are always true. We also have quotient identities. We've talked about these as well. Tangent is sine over cosine, and cotangent is cosine over sine. We use those for our unit circle a lot. The next one that we have is Pythagorean identities. Sine squared theta plus cosine squared theta equals 1. Tangent squared theta plus 1 equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. These are a little more difficult to memorize, and we have not actually really used these yet, so these are brand new. One thing that can be helpful for this is if you can just remember the first one, you can develop the other two from the first one. So for example, sine squared theta plus cosine squared theta equals 1. You have to know that one, have it memorized. But sine, if we divide it by cosine squared theta, it gives us tangent squared theta. So this is something that we can do as long as we divide everything else by cosine squared theta. And so sine squared theta over cosine squared theta is tangent squared theta. Cosine squared theta over cosine squared theta is 1. And 1 over cosine squared theta is secant squared theta. So if we take sine squared theta plus cosine squared theta equals 1 and divide everything by cosine, we get the second trig identity here. The same thing is going to be true for the third trig identity for the Pythagorean identities if we divide by sine. So if we divide by sine squared theta for the whole equation, then we will see sine squared theta divided by sine squared theta is 1. Cosine squared theta divided by sine squared theta is cotangent squared theta. And 1 over sine squared theta is cosecant squared theta. So that gives us this third Pythagorean identity. So that may help you remember those last two. Okay. Our last set of trig identities are the opposite angle identities. And if we take sine of negative a, it will give us negative sine of a. If we take cosine of negative a, it will give us positive cosine of a. So for example, here, sine of negative pi over 6 is going to be negative sine of pi over 6. And sine of pi over 6 is on the unit circle, and so we know the sine of pi over 6, if we think of the unit circle, at pi over 6 right here, the coordinates of that point are root 3 over 2, 1/2, and sine is your y coordinate, so you would get negative 1/2 as your answer here. If we're finding cosine of negative 3 pi over 4, cosine of a negative number is just the same as cosine of that positive number. So cosine of 3 pi over 4 is going to be equal to the cosine of negative 3 pi over 4. So 3 pi over 4 is going to be found over here in the second quadrant. And cosine of 3 pi over 4, our coordinates here are negative square root of 2 over 2 and square root of 2 over 2. And cosine is our x-coordinate, so we will get negative square root of 2 over 2. Okay. We don't use this one as extensively as we will use the others, because you could also figure this out just by using other methods that we have used for the unit circle. So you do need to know these, but they won't be used quite as much as the others. So all 4 sets of these trig identities are going to be on a quiz that we are going to have on Wednesday. And that quiz will just be a paper that says reciprocal identities, and it will have 6 blanks underneath it. And that will say quotient identities and have 2 blanks, and Pythagorean identities and have 3 blanks, and opposite angle identities and have 2 blanks. So this is another memorization quiz. So if you are, because you have to have these memorized in order to be able to do anything that we're getting ready to do. Alright, so let's look at some problems that you'll be asked to do with these. So the first thing that you might be asked to do is use identities to find trig values. So, for example, if we know secant of theta is 3/2, and they ask us to find cosine of theta. Well, we know that cosine of theta equals 1/secant of theta. That is one of our identities. So if I know secant of theta is 3/2, then cosine of theta would have to be 1/3/2. And 1/3/2 will do 1 times 2/3, which will give us 2/3. You'll notice these are called reciprocal identities because when you do that, it just flips the fraction. So knowing that, if I see secant theta equals 3/2, I know cosine of theta is 2/3. If I know, another example, if I know tangent of theta is 4/5, then I know cotangent of theta is 5/4. So if you get the reciprocal identities, they are the easiest to do. Example 2 gives us cosecant and asks us to find tangent. Well, if we look back through our identities, opposite angle identity is not going to help us there. It just deals with sine and cosine. The reciprocal identities do not help us because tangent and cosecant are not reciprocals of each other. Our quotient identities do not help. Tangent and sine and cosine doesn't deal with cosecant. But if we look at our Pythagorean identities, we do have this trig identity that has tangent and secant. We also have this one that has cotangent and cosecant. So we can use either one of these right here to help us out. Now, none of the identities have tangent and cosecant, but we can use a reciprocal identity to help us with that cosecant becoming secant there. So, if we go back to the problem, we know cosecant of theta is -4/3. So, what we can do here, if we want to find tangent, we can use the 1 plus cotangent squared theta equals cosecant squared theta. And we can find cotangent, and then once we find cotangent, we just have to flip that to find tangent. So we've got 1 plus cotangent squared theta, and cotangent is what I want to find. It is supposed to equal -4/3 squared. And so 1 plus cotangent squared theta is going to equal 16/9. If we subtract 1 from that, 16/9 would be 16/9 minus 9/9 if we get common denominators. So for that, we would get 7/9. So cotangent squared theta equals 7/9. At this point, I'm going to go ahead and switch. That means tangent squared theta would have to equal 9/7. And we could square root both sides to get rid of the square. So when we do that, we get that tangent of theta equals the square root of 9, which is 3, and over the square root of 7. And when we square root both sides, we've got to put a plus or minus right here. So we also would probably need to rationalize this denominator, so we could multiply by square root of 7, top and bottom. So tangent of theta equals plus or minus 3√7/7. However, we can't have two answers for this. So there was some information at the beginning that I kind of ignored whenever I was doing this problem. It tells me that pi is less than theta less than 3pi/2. So on your unit circle, right here is pi, and right here is 3pi/2. So if they tell us that theta is in between these two values, they're telling us that we're looking in that third quadrant for our answer. So in that third quadrant, both coordinates are negative, so sine and cosine are negative, but tangent is sine over cosine, which is going to be a negative over negative. So we'll actually get a positive for the tangent. So our final answer here, tangent of theta, is going to equal positive 3 square root of 7 over 7. Now, if that had been a different quadrant, we would have chosen the negative. Okay? All right. The next thing that you're going to be asked to do is you're going to be asked to simplify trig identities. So basically, you're using those identities that we know, and you're replacing them with another known fact so that we can simplify this expression. So, for example, here I've got sin x plus sin x cotangent squared x. So one strategy that we sometimes use is that we can factor something else. If I look at this, I've got a sin x and a sin x with both of these. So I could take sin x, I could factor sin x out, which means that I'm dividing by sin x. I don't know what that's doing. So right here, I just get 1, this would cancel. Here the sin x's would cancel, and I'd get plus cotangent squared x. Well, 1 plus cotangent squared x is a trig identity, and 1 plus cotangent squared x equals cosecant squared x. So I can replace 1 plus cotangent squared x with cosecant. Well, we can also use some reciprocal identities here. So sine of x times cosecant is 1 over sine squared x. And if cosecant equals 1 over sine squared x, we get this expression here, which I can put that sine x over 1. I can multiply straight across. So we get sine x over sine squared x. If you want, you can think of it like this: sine x over sine x times sine x. And so the sines both will cancel there, and you will end up with 1 over sine x. Now, reciprocal identities tell us that 1 over sine x is cosecant x. So we have simplified down this expression to where we could just write cosecant x. So if I plug in 30 into the first expression and 30 into this expression, I'll get the same answer. We have these two answers are these two expressions are equivalent to each other. Okay. In our next example, we've got 2 minus 2 over cosecant squared theta. Well, in this particular case, it might be helpful. Typically, we don't usually like to deal with cosecant squareds, or cosecants, or secants, or cotangents, or really even tangents. So it might be helpful if we change this. So I'm going to change this to 1 over sine squared theta. And dividing fractions is easy as pie. We can flip the second and multiply. So 2 times sine squared theta over 1 is what we're going to end up with when we do that. And so we'll get 2 minus 2 sine squared theta. And we can use that same strategy we used before, where we could factor out a number. So we could say 2 times 1 minus sine squared theta. Now, something to take note of. We know that sine squared theta plus cosine squared theta equals 1. That is our first Pythagorean identity. We need to make sure we have that memorized. But something almost as good as knowing sine squared theta plus cosine squared theta equals 1 is this. If I subtract sine squared theta from both sides of this equation, then cosine squared theta equals 1 minus sine squared theta. This is not an identity that you're going to be tested on the quiz, but this is a very important identity, or a version of the same very important identity that we're going to have to know. So when we see 1 minus sine squared theta, that equals cosine squared theta. So we can take this 1 minus sine squared theta and replace it with cosine squared theta. And so that would be our answer for this problem. Okay. Our next example, we have sine x plus cosine x squared plus sine x minus cosine x squared. So for this one, sine x plus cosine x does not equal 1. Sine squared x plus cosine squared x equals 1, but this expression does not equal 1. So what we're going to have to do here is we're going to have to expand both of these. So whenever we see sine x plus cosine x squared, that means sine x plus cosine x times sine x plus cosine x. This one's going to get a little bit long. And same thing over here, we'll have sine x minus cosine x times sine x minus cosine x. And you could square, double square here. You don't necessarily have to write it out the long way. When you multiply, you will get sine x times sine x is sine squared x. Sine x cosine x here. You also get a sine x cosine x here, so you'll get plus 2 sine x cosine x. And then cosine x times cosine x is cosine squared x. And then over here, we're going to multiply those together as well. Sine x times sine x is sine squared x. Here you'll get a negative sine x cosine x. And in the middle, you'll get another negative sine x cosine x. So that's going to give us minus 2 sine x cosine x. And then the last part, cosine x times cosine x, is going to give you plus cosine squared x. And so you've made this really long here, but there's some really cool stuff that's going to happen next. Because I've got a positive 2 sine x cosine x, and I've also got a negative 2 sine x cosine x. So those two terms cancel each other out, leaving us with sine squared x plus cosine squared x plus sine squared x plus cosine squared x. And sine x squared plus cosine squared x is 1. So we just end up with 1 plus 1, which is 2. I love these problems because they start off very complicated. Sometimes they get even worse, but often their answer is as simple as just a single number. Okay, and here's our last example. We've got 1 plus cosine x times cosecant x minus cotangent x. So what we can do here is we can distribute. And so we will get cosecant x, and we'll get minus cotangent x. We will get plus cosine x cosecant x. And then we'll get cosine minus cosine x cotangent x. Now this looks bad, like there's probably not much you can do with this. But what we can do is we can now change everything to sine and cosine. So cosecant is 1 over sine x. Cotangent is cosine x over sine x. Then we'll have cosine x times 1 over sine x, and cosine x times cosine x over sine x. And the neat thing here is everything is over a sine x, so we've got common denominators. Now, this negative cosine x over sine x and the positive cosine x over sine x, if we multiply those together, those terms are going to cancel each other out, just leaving us with 1 minus, here you'll get cosine squared x all over sine x. Okay, there's still more that we can do. 1 minus cosine squared x equals sine squared x, like we saw before. So I can write this as sine squared x over sine x. So I have 2 sine x's on the top, only 1 on the bottom. If I cancel those out, I'm just going to get sine x as my answer. Okay, these problems are really difficult to know what to do at first. At this point, I would just like for you to be able to follow my work and try to start a few of these on your own. We will work on these for several more days. Your assignment that you're going to do for me is page 428, 25 through 35 odd, and then 44 through 53 all. Some of these, the 44 through 53 all, are probably going to be pretty difficult. You don't necessarily have to get finished all the way to the end with them, but at least try something on them. Also, we'll have a quiz on Wednesday on identities, and you need to know all these identities, so study for that.